MCEN 1131 Engineering Mechanics Statics Equilibrium Part 2 Prepared by Mirko Domanovic. Introduction. Before proceeding any further, it is suggested that you ensure your familiarity with the previous lesson titled Equilibrium Part 1. This lesson is essentially a continuation of the principles learned there. Let's recall that a free body diagram is a diagram that shows an object or body with all supports removed and replaced by the forces acting upon it. The process of drawing an FBD is most easily explained using an example. To fully describe the sequence of steps, including the suggested first steps, consider the structure shown below in Figure 1. Start with the basics. Give your FBD diagram a title. Redraw the entire frame but without any supports, as shown in the figure on the left. A stick diagram is easy and will often suffice. Next, identify all points of the diagram where there are external forces and or supports, as shown on the figure on the right. Proceed to draw any given forces, as shown in Figure 3.3. Be sure to indicate slope, direction, and magnitude. Note point A in Figure 3.4. Because we assume no friction at this point, the force there must be perpendicular to the sloped surface. Note point D in Figure 4.5. Both the horizontal and vertical components must be shown at this point. We can safely assume the directions of dx and dy. Finally, after labeling all of our distances and points, as shown in Figure 4.6, our FBD diagram is complete. Now consider section BG from Figure 1 several slides back and perform the same steps. Finally, do likewise for member AD. The three equations of equilibrium. Understanding this section will be easier if we consider only coplanar forces. Recall from a prior lesson that coplanar forces are those that act in only one plane. Also recall the definition of static equilibrium. The chair in which you sit in is in static equilibrium. It is not moving up or down. In other words, the total upward vertical forces acting on the chair are equal to the total downward vertical forces acting on it. Finally, recall that for static equilibrium, three requirements must be met. 1. The vertical forces must be in balance. 2. The horizontal forces must be in balance. And 3. The moments about any given point must also be in balance. Consider the coplanar system shown here, as well as its free body diagram. Note that there are only two horizontal forces shown in the free body diagram. Consequently, we can solve for A subscript x, as shown in this slide here. Conversely, there are three vertical forces, two of which are unknown. As a result, we cannot use the sum of vertical forces is equal to 0 formula. If we calculate the moments about A, then A subscript x and A subscript y will not appear in the equation, and we can solve for B as shown here. Taking the moments about B will allow us to solve for A subscript y as shown here. Homework. Read Chapter 4 up to page 105. Complete the practice examples and problems from the book as well as those provided by the instructor.